Thank you so much. I appreciate you having me here on this lovely recorded session, just like every other virtual conference. Oh, I'm being told this is not a recorded session. This is actually live. Excellent. Really happy to be here, following a lot of really great sessions today. I'm really grateful for being a part of it. I do not have a bunch of super awesome history lessons for you at this point in time. We're going to talk about infrastructure as code. We're going to talk about dynamic environments, and we're going to talk about speeding stuff up. As my intro said, I'm currently a DevOps advocate with M0. We do infrastructure as code automation and stuff like this. This will not be a sales pitch. I was a cloud developer advocate at VMware. I focused on a lot of our SaaS, stuff for public cloud. Before that, I was an enterprise architect and infrastructure operations. Overall, I am the ops of DevOps. So I come from the infrastructure side. I can develop, I can write code. I don't like it, and I am very bad at it. But really, the point of operations, the point of infrastructure, there's, you can't just deliver it just for the sake of delivering it. You have to deliver it for a reason. Infrastructure is delivered because of the application. The application is what runs the business. That's what makes people money. That's really where everybody's focus area is. So throughout my career, I've always been focused on the application. Going through figuring out how we want to architect it, how we need our uptime, how we need specific hardware that has specific requirements and things like that. Everything is always focused on that. So that's kind of why when I came to VMware, I got into the software industry, I really started focusing on the process and procedure and DevOps and the tooling and things like that. DevOps is not just software. It's not just, here's my CI/CD pipeline and I have DevOps now. It's a mixture of the tooling and the processes and the procedures and the people. You kind of have to make everything work together so that you can really start to speed up, fail faster, figure out how to get where you need to go, be more agile, and all those other buzzwords and things like that. This is a lovely agenda that talks about some certain things in certain order, and I'm going to skip that because I don't like those. Key terms. So static environments and dynamic environments. It's kind of the overall, or the overarching theme of why I'm giving this talk. Static environments are long-term, purpose-oriented environments. You can think of it as your development lab. You may not have the same kind of thing these days if you're using public cloud, but really, the old school development labs where you had a stack of hardware, it had a copy of your application. If you were lucky, maybe you had 2 stacks of hardware, maybe you had 2 copies of your application. And it just allowed you to, test out patches, do things you needed to do. But really, overall, there was a lot of pain points involved with that. I was in charge of several labs just like this. The new way of doing this is dynamic environments. And these are temporary, ephemeral, really short-lived, very purpose-built environments that you spin it up, you do what you need to do, you burn it down, you move on to the next one. And that's really kind of what we're talking about here, is how to get from static, long-lived environments to these short-term, ephemeral, dynamic environments that allow you to move forward and develop at a lot faster velocity. So why dynamic environments? I have been in charge of many labs over my career, and there was one of them where one of my key jobs was who's on dev. I had to kind of coordinate the schedule of who was allowed to come in and do what at what given time. If somebody rebooted something or needed to reboot something, I would have to figure out who was doing what, if it was going to mess with anybody else. If somebody was going to implement a breaking change, we had to make sure that it wasn't going to mess with anybody else. It's a real pain. I didn't like doing that, but hey, that was the job at the time. I learned a lot about that. And that's one of the reasons why I enjoy working in the DevOps space so much, is because it kind of fixes a lot of those problems. It allows you to move a lot faster. It allows people to have these dynamic environments. Always having matching production. So when you are doing these environments correctly, if you are using, infrastructure as code and things like that, you're always building these environments off of the main branch. You may have your, feature branch or your development branches, things like that, but the main branch is kind of the single source of truth for what production looks like. And if you're always building these off of that, then you kind of always go through and have the most up-to-date version. Now, of course, if you're doing a pull request branch or something, that's going to pull a copy of the code from the main branch. So, you are where you are. It's a lot easier to share and collaborate. Everybody has their own little bubble. You can give that bubble to somebody else. But really, at the end of the day, once you're done with it, you burn it down, you move on, you get another one. I'm sure everybody's probably seen a version of this slide at some point or another. I've presented a version of this slide 50,000 times. And I wish I could stop, but it really helps kind of illustrate the point of, way back when static environments were so prolific simply because of giant monolithic applications. They really didn't change too much too often. You built them up. They didn't have a lot of patches. You weren't necessarily going through and you didn't have a fast velocity. You were doing waterfall. So you were testing out, you were going through, you were planning it out, you were making your updates and then going through. That really facilitated those static environments being okay. Nowadays, with cloud native architecture, with microservice architecture, the fact that you're changing pieces in and out a lot, you're upgrading, you're adding, removing, it really is a completely different process of development. It's a different architecture. And it actually kind of enables the use of these dynamic environments a little bit better because you are making just tiny little changes. You're not needing to completely refresh the whole stack. It kind of allows you to be a little faster. It also allows you to need to go a lot faster. So if you are doing this and you're using a static environment, that can really slow you down. It really cuts into your ability to be agile, to be fast, to, release out to the customers as much as you can and as fast as you can. So develop more and more infrastructure these days. From the operations and the infrastructure side, that was always called shadow IT. From the developer side, it's just called doing their jobs. I can't count the amount of times that I had problems with developers that I was working with going out and swiping the credit card, doing what they needed to do in the cloud when I'm trying to give them exactly. All the problem was I wasn't able to give them what they were asking for as fast as they were asking for it. They need to be able to work faster, meet deadlines. They may need to burn something down and rebuild it really quickly because their patch didn't work or what have you. That was always a problem to me, but I just simply didn't understand the other side of the argument that I wasn't able to produce fast enough. I thought I was giving a fine cloud infrastructure, not so much. So they're going out, they're swiping the credit card, they're doing their thing, they're deploying infrastructure, but developers, for the most part, historically aren't infrastructure folks. They don't necessarily know what they're doing. They're not necessarily going out and clicking. They're not installing a bunch of software and doing what they need to do. And that's really where the infrastructure as code model comes in. This child of a developer that needs to do infrastructure. Instead of going through and logging into the cloud console and clicking around and saying, I need 3 EC2 instances, I need an elastic load balancer, I need a database for this with RDS and connecting all that together, they've got code. That's the language that developers speak. So when you are able to take and write the code to create the infrastructure that you need, then that's a little, faster. It's a little more in their wheelhouse. And this is really the way that most developers these days are going through and deploying infrastructure. Now, when it comes to infrastructure as code, there's a ton of different choices here. I've had some folks come up to me after this talk and kind of say, hey, I thought you were going to tell me exactly how to get to faster development with infrastructure as code and dynamic environments. But unfortunately, I can't tell you that step by step by step. And the reason for that is the 100% traditional engineering answer of it depends. There are so many different variables that go into decisions of what cloud are you going to choose? What type of application do you have? What kind of resources are you looking at? How often are you looking at rebuilding the stack? Since so many different variables there, I can't really tell you. So we're going to kind of talk about a little bit of the different choices that you can make, maybe some of the pitfalls that come along with that. And we're going to start with the different infrastructure as code choices here. Now, the first thing you got to kind of figure out is, are you going to go with cloud specific? Or are you going to go with cloud agnostic? If you are 100% all in with AWS, most likely you are either already using CloudFormation or you're thinking about using CloudFormation. If you're on Azure, then you're looking at ARM templates and things like that. Those are absolutely great. They are purpose-built infrastructure as code for a specific cloud. Now, what if you are multi-cloud, or what if you're going to possibly be multi-cloud, or what happens if your CTO one day comes through and says, I'm tired of Microsoft, we're going to Amazon, or vice versa? You're kind of stuck if you choose those. Now, there are tools out there that will help you to convert ARM to CloudFormation. Of course, some of the resource names and things like that are different. But really, there are some tools to kind of help you do that. But you could really solve that problem and reduce a little bit of headaches for yourself long term by choosing a cloud agnostic framework for that. And that's where Terraform comes in. Terraform is the de facto, I don't want to say winner, but they're the industry standard for infrastructure as code these days. There are Terraform modules and providers for pretty much every cloud at this point, and not just clouds, but also third-party SaaS tools. And I believe there's actually some modules out there for hardware. I think F5 actually has one for their load balancers. So I mean, you can control just about anything with Terraform these days. And if there's not a provider for it already, you can actually go in and create your own provider for it. It just ends up being a wrapper on the API that you already have access to. So that allows you to really kind of have the freedom and flexibility of, hey, I need to go across clouds. Now, of course, some of the syntax isn't right. You'll need different providers, different types of resources, but it'll be a little bit easier for you to change that stuff based on that current stack versus having to go through and, rewrite it from scratch. Now, with that, Terraform is its own language. So you will need to learn their language in order to go through and write that. There are certain ways of augmenting that a bit. TerraGrunt, for example, which I have the logo of here. TerraGrunt, their main purpose is as a wrapper around Terraform is to help you dry your configs. Dry as don't repeat yourself. And with that, that'll allow you to kind of have it to where if you have, say, your infrastructure as code files for production and for development and for staging and what have you, you don't have to have entirely separate copies of each one. You have one copy of the overall configuration, and then you just have tiny little configuration files for each one of the specific environments because your IP addressing scheme may be different from prod to dev, or the naming scheme may be different from prod to dev. So you want to be able to change those variables a little bit without having to have completely separate hard-coded versions for each one of those. Now, like I mentioned with Terraform, you do have to learn that new language, and that's really where things like Pulumi come in. And Pulumi is starting to have a lot of traction in the industry these days, and it is an infrastructure as code framework, but it allows you to work with the code and the language that you're already using. If you're writing in Go, if you're writing in JavaScript, then great, use that, and that will allow you to build your infrastructure as code from that. You'll see that, I would expect, more and more these days, but at this point, really, Terraform kind of seems to be the one that has jumped up over all of it. So you'll see a lot of that going forward. But really, this is one of the choices that you have to make is, are you going to go cloud specific? Are you going to go cloud agnostic? Do you want to learn a new language? Do you want to use the language you're already using? There's all of these variables that kind of go into that first step of what infrastructure as code framework should I work with? And then we actually have to move to infrastructure as code. So there's a lot of different things that you can do here. Do you want to start fresh? I can tell you right now, I've never seen somebody do this except for one time, and they were looking at updating anyways. So they took their old monolithic application and were able to actually migrate off of that to a newer application stack. They built the infrastructure as code files from scratch, so they were able to complete that re-architecture. So they had a repeatable model inside of their Terraform files. That's not the norm. Most people will end up, taking the existing applications, the existing configurations that they have, and trying to work backwards to create infrastructure as code files for the stuff they've already got. Now, there are tools out there to help you with that. For example, Terraformer from Google. That will actually allow you to point you're pointed at the cloud, and I believe it's GCP, and there may be a little bit of AWS. I haven't actually tested that out, but for sure works with GCP. And I believe there are some other tools that will help you do it for the other ones as well. But it'll actually allow you to take and point at the cloud and say, this is my application stack. It will then go back through and write the infrastructure as code files for whatever's actually deployed. That's kind of the opposite of starting from scratch, where you write your infrastructure as code files and then deploy from that. This will then write back those files from what's already deployed. So you kind of have not only to go through and pick what kind of framework you're doing, you have to kind of pick your approach. How am I going to do this? How am I going to get from where I'm at now to where I want to be, which is a templatized cookie cutter version of my application and my stack that I can repeat over and over and over again to help me deploy a lot faster. Now, once we're doing this with dynamic environments, you can go through, you develop on your local machine, you can create a pull request for that code, you can do all of your end-to-end testing on your dedicated infrastructure. Each one of the developers can have this specific, workflow. You can have your own environment to go through and deploy from. Then it goes to back to that shared model where you're merging everything back to the main branch. Everything gets pushed into production, you can redeploy out. And then, rinse and repeat. Go through, open up a new PR, start working again, get a new environment off of that new code base, and then do it over and over again. So that's kind of a look at what that workflow looks like a little bit. So actually going through and setting up the dynamic environments. So we've talked about why you might want to go to dynamic environments, some of the benefits. We talked about infrastructure as code and kind of what that is. Going through and picking your framework. Do you want to be cloud agnostic? Do you not? Then you've got to be able to go through and actually set that up. Once you figured everything out, the main first thing is templatizing that infrastructure. So that's going through all of those past steps that we kind of talked about, making all those decisions that you need to make. Once you templatize that infrastructure and you can make that a repeatable process, that's where you need to figure out your strategy. So are you going to do per pull request environments? And that means every time a pull request is opened, a new version of that application is then pulled up and spun up off of that code base. Every time you commit, it can go and redeploy so you can test. Are you going to do per developer environments? So every developer, whatever task they're working on at the time, they just spin up their own. Now, that could also be a per pull request strategy, but sometimes it's not. Do you want to do time to live so that if they spin something up, it's only available for a week or a month? That really helps you kind of cut down on waste. You got to kind of figure out what that strategy looks like, how you're going to do that. I actually had a comment from somebody say per Jira, as well. And Jira kind of makes me have bad flashbacks and I don't care for it. But yeah, absolutely. You can do a per Jira's, environment strategy. You just got to kind of figure out what works best. And this is one of those things where you don't necessarily have to completely change the way that your development process works in your development cycle. You can make this work for the way that you want to do the development. The last thing that you got to do with this is you have to implement the deploy and destroy automation. You've got to be able to take that repeatable template that you created and then make sure that it's either automatically spun out or that you have an easy way of triggering that. And it's got to be all the way from deploy to destroy. So if you just go and you start spinning out all of these different environments, you're going to have a lot of cloud waste. You're going to be, possibly sitting there with a bunch of environments that you're not using anymore. So being able to have that entire life cycle managed is something, that can be very helpful. It can make sure you're not wasting any resources. You can schedule those environments and things like that. This is where we get to the slide that looks like I'm trying to sell you something. And yes, we do this. But we also have some others in the space with Scalar and Terraform Cloud and Spacelift, as well as CI/CD pipelines themselves. We kind of fit specifically into a little niche that a guy in the community named Eric Osterman of Cloud Posse, he does the Sweet Ops DevOps office hours every week, which is a really great Zoom meetup every Wednesday. And there's also a really awesome Slack channel involved with that. And he actually coined a term called tacos, and that's Terraform Automation and Collaboration Software. Now, while you can use CI/CD pipelines for this, there are orbs for Circle CI and things like that you can put in there. You can put modules in Jenkins in order to run Terraform. They're not really purpose built for that. They're not really caring about the life cycle of that deployment. CI/CD pipelines are very prescriptive. They're going to go through and they're going to run step by step by step. Once the pipeline run is done, they're going to wipe their hands of it and be done with it. Those of us taco platforms, we're actually going to work with the full life cycle of that deployment all the way through. That's where you can go through and set like those time to lives. You can set policy. So if you want to set a policy of, with this environment, they have a max node count of 3 or 4 for Kubernetes clusters, and you want to make sure that you're enforcing that. We allow integrations with that as well. So it's really finding a platform that does it for you. If you're using Jenkins already, if you're using Circle, if you're using, any of those, great. They will allow you to automate that Terraform. If you're looking for something a little more, look into the Tacos platforms. Any one of us can kind of handle exactly what you're doing. But really, you have to find something that's going to automate that life cycle. If you're still doing all of your Terraform runs from your laptop at that point, that's not really going to scale. There's a lot of problems that come along with that. You're going to lose visibility into who's deploying what and where and when. Now, of course, you've got logs in the cloud that tell you what's out there, but it may be a little difficult to be able to say, hey, what environment is this? What pull request is this associated with? What variables did they use for that deployment? So centralizing your Terraform runs, be it whatever platform you do that with, is going to save you a lot of problems down the line when it comes down to actually scaling across teams. Now, if you want to learn more, you can skip out on the 2 on the outsides, but really Twitter is the best way to get me. You can email me, you can call my phone, and I will possibly not answer or not see that email. If you want to get a hold of me, ping me on Twitter, and if I'm not asleep at that very moment, I'll get back to you pretty quickly. I am at VTimD. I'm always on there. I love Twitter. It is part of my job. It's part of my personal life. There is such a fantastic technology community out there. I know that you've heard, about Twitter before today. If you're not on it, you should get on there, even if it's just for learning tech news and stuff. It is a fantastic resource. There are so many great people that are out there and ready to help you, including people that if you have a problem with product X, Y, or Z or something, you can probably get help from somebody who actually wrote the book on that product. So I definitely, I'd push you to get out there and get involved with the community, get engaged. If you haven't spoken publicly before, definitely give it a shot. Like I said, I'm extremely honored to be a part of the awesome, group that's been speaking today. I appreciate everybody taking a look and, joining the session. Feel free to reach out if you have any questions, comments, concerns, or anything like that. And I look forward to hopefully talking to you again next year.